All right, we're going to go ahead and get started. Good morning, everyone. Thank you for joining us today. We have a great webinar for you today on the topic of our PCIe Application Accelerator card. This is one of Huawei's hottest selling products, so it's definitely exciting for us to talk about it. We have two presenters this morning. One is going to be Dan Wattleworth, who's one of our channel sales managers in the central region, and also Mohammed Moshref, who is the absolute expert on the Tecal ES3000 Huawei's PCIe card. Before we get started, just to let you know, if you have questions, please enter them in the Q&A panel within your GoToWebinar interface, and we'll address all those questions at the end. And also, we're going to be recording this webinar, and it will be available for view or for you to forward a link on to other colleagues who may have missed the webinar. So with that, we're very excited, and I'm going to go ahead and pass it over to Dan Wattleworth to kick us off. Go ahead, Dan.
Great, thank you, Nick. Well, we appreciate everybody being here this morning. I'm excited about this webinar because we've got a fantastic product that we'll be introducing to you and telling you more about and how it can help you in your particular businesses. I want to start out by talking real quickly about why I love working for Huawei. And really what it comes down to is that our value proposition is very simple. It's high performance, low cost. And in the real world, what that comes down to is I get to go out and meet with our channel partners as well as customers every day and help them solve their IT challenges. Pretty much every customer that we run into has a long list of IT projects that they would like to get done. Every IT manager that I know has a million things that they'd like to do to help their users to have a better experience, help their network run faster, whatever the case might be. But there's always a long list of projects that could be done, and on the other side, there's a very limited budget in order to do that. And so one of the reasons I love working for Huawei is that we get to help them solve that challenge with our high-performance, low-cost combination. So one real-world example of that that hits close to home for me, and there are many, many of these types of examples, but there's a school district that is very close to where I live. Some of my friends, or my kids' friends, attend that school district, and they were in the middle of a network refresh cycle, and so they were going to refresh their wired network, but they also had huge needs for wireless because of the BYOD initiative that had been handed down, and they just did not have the infrastructure in order to support that. So we were able to go in and compete very well with some other vendors, and in the end, we were able to provide this school district with not only their wired network refresh, but an entire wireless solution on top of it, and still fit within the same budget that they were planning to use for their wired-only network. So again, a very specific example, but these are the kinds of things that we love doing day in and day out, is getting down in the trenches with our partners and customers and figuring out how we can fit more of your projects into your budget. Now, one of the interesting things about working with Huawei is that being fairly new to the U.S. market, not a lot of people know who we are, so we always have to start with how to spell Huawei and then how to pronounce it. In fact, last week I was getting some materials printed and walked into a shop, and it had been a few days since I'd placed the order, and so everyone there at the shop was arguing with each other about how you pronounce Huawei. They'd seen the logo and the name and had no idea how to pronounce it, so they were placing bets on how you pronounce it. So we do get that from time to time. But one of the purposes of today's webinar really is to introduce you to Huawei as a company, as well as a very specific product to meet your application acceleration needs. So let me get in real briefly to who is Huawei. So Huawei may be the biggest company that you've never heard of or haven't heard much about. We are a global information communications technology provider. Fortune 500 company. Last year we came in at Fortune 385, so very, very large company. And if you want to put that in perspective, we did just under $40 billion in revenue last year in 2013. Cisco is a little bit higher than us. I'm sure you've heard of Cisco before, 42 billion or so. And so in terms of worldwide scope, we are a very, very large company. Some of the things that you may not know about us is that we do serve as the backbone of the network of 45 of the world's top 50 telecoms. We operate in 140 countries, and approximately 1/3 of the world's network traffic flows through our network. You may also not be aware that in the worldwide markets, we are number 2 in video conferencing and number 3 in smartphones, behind only Samsung and Apple. Again, in terms of our size, we've got 150,000 worldwide employees. Almost half of those are engaged in research and development activities. We are very, very big into innovation, research and development. In fact, we spent $5.5 billion last year in R&D, which accounted for 13.6% of revenue. I'm not aware of any other major technology companies spending either that much in terms of raw dollars or percentage of revenue on research and development. So again, you can get a sense for the commitment that we have to today's technology as well as innovating tomorrow's technology. One last point of emphasis here. Just wanted to give you kind of a broad sense for the markets that we play in, the products that we make. I mentioned a few of them a minute ago. So everything from video conferencing, where I mentioned that we're number 2 worldwide in those types of products. We also have a wide enterprise portfolio with servers, storage, networking, both campus as well as core networks, security products, unified management, etc. And so quite a wide range of products that we offer across the board for all of your enterprise needs. So that's a little bit about who Huawei is. I want to take a minute and just introduce our main presenter for today, who will walk us through our PCIe application accelerator cards. Mo Moshrif is our Senior IT Storage Solutions Manager, and as Nick mentioned a minute ago, he is the expert in all things PCIe SSD cards. So at this time, I'm going to turn the time over to him, and he will walk you through this particular product. One of the main reasons that we wanted to bring it to you today is because, again, it goes back to our value proposition, which is high performance, low cost. And he'll talk about how we compare to the other products that are out there in the market, and you will be shocked at how much less expensive we can deliver that solution to you than what our competitors do, even though our cards far outperform our competitors. So, Mo, I will turn the time over to you, and you can give us all the details.
Great. Thank you very much, Dan, for some introduction to the Huawei. So I'm here at Huawei Enterprise. As Dan indicated, we have different business units. Huawei Enterprise is headquartered in Cupertino, California, very close to Apple. My focus is storage, server, and PCIe SSD product line. So next slide, please. Basically, the goal of this presentation is to give you a good perspective where the SSD fits today into the market. As we know, the CPU has ramped up, and Intel just announced their Haswell platform. That means more core, up to 18 core, is going to be available. That means higher computing. HDD never catch up. They keep increasing the capacity, obviously, that is needed for big data. However, when it comes to the bottlenecks that it creates today for the performance and the latency, you need another sort of storage, and that's what SSD comes to picture. And SSD, of course, comes in a different form factor. I'm going to go through that, but our focus today is going to be PCIe SSD. That is the standard, is very well known. But the SSD definitely here is a very disruptive solution in the market. All the big companies such as Facebook, LinkedIn, Google, they have been asking for, faster SSD, but kind of a better market pricing. I will touch base on that as well. So the purpose of this slide is SSDs here, and it's going to keep going. Next. So what is SSD? SSD is basically a NAND flash memory, which was introduced back in 1962 by Hitachi and has been evolving ever since. The first major production of the SSD form factor came as a SLC, which is a single level cell. And the difference between the SLC, MLC, EMLC, and TLC, just to give you a good understanding, is really the longevity of the SSD or the NAND flash itself. SLC provides you the longest long life as far as the number of write that you can do, up to 100K. Of course, is the most expensive one. But as I indicated earlier, companies such as Google, Facebook, LinkedIn came to the market leader, to the manufacturers such as us and Samsung and other Toshiba, and say, well, SLC is very good, but we need something cheaper, and we don't care if it's the average life is like half of it or 1/3 of it. So MLC was introduced to the market. That's a multi-level cell. Then they kind of tweaked that and said, well, MLC is wears out too fast, give us something in between. Then EMLC, which stands for Enterprise MLC, was improved version of the multi-level cell, and it gives you almost half of the life of the SLC with a great price performance. So the whole market now has gone through the EMLC implementation. And TLC is, of course, another level, which is a triple level cell devices. It's very targeted for consumers. You hardly see TLC being used for the enterprise, such as the PCIe card that we have. Next, please. So as Dan indicated, Huawei has been in business for a long time. Obviously, Huawei started as a telco carrier business, very solid product line. But SSD also is not new. So the purpose of this slide is we just didn't come to the market like, say, last year. SSD, the first product line, was introduced in 2007. And he's been evolving ever since. Now we just introduced the V3, which is like a fifth generation of the SSD product line. That's with a higher capacity, up to 3.2 terabyte, as well as we introduced half height, half length. The current PCIe that mainly I'm focusing today is a full height, full length, because the only way you can capture the high performance, low latency, you have to have that form factor. However, if there are some customers that requires half height, half length, lower capacity, we also have that offering starting last month. Next, please. I just want to give you a feedback of where PCIe SSD fits into the implementation of the pictures. To the right, of course, is the hierarchy of the storage. We know the flash, L2 cache, and standard L3 cache, they're obviously in the top of the hierarchy. But PCIe SSD fits right there. But I want to focus on the left-hand side where it shows the CPU and memory. So the industry is moving, the whole industry is saying, bring the storage closer to CPU. But why PCIe SSD? It's very simple. The whole industry understands PCIe standards. There is no hidden secret. Every company that makes the server from the low end to the high end, they have to follow the same standard in PCIe form factors, as well as providing the power and cooling. So there is no hidden agenda. You don't have to reinvent the wheel. So when you install the PCIe SSD into your server, it's just like your HPA card. It gets boots up, it recognizes the OS, the driver gets loaded, and you're up and running within half an hour. It's that simple because of the standards that are very long. So that's the purpose of this slide. Of course, I have some numbers in there as well that I'm going to provide you again with more details about our performance and our latencies. Next, please. So who is using PCIe SSD? I have categorized it in ISP. What is the ISP looks for? Searching massive random read write. Those are the applications that our PCIe SSD as well as competition will fit very well. Anybody that does lots of random read write, they can take advantage of PCIe SSD implementation. As well as caching, then again goes back to the read write performance, and database. So majority of the first implementation of the SSD as well as PCIe SSD was really into the database environment such as SQL, now with the new open database such as NoSQL, MongoDB, HB. those are the ones that can take advantage of the PCIe implementation. We have implemented quite a bit into the SQL shops, as well as other databases. Another enterprise and finance that can take advantage of these PCIe implementation, obviously the OLTP. Finance was the first industry that really took advantage of SSD implementation. They were willing to pay the high price even for the SLC implementation. So they are taking advantage of the PCIe SSD implementation hugely. Then we got SMBs. You got lots of CRM, database performance, low latency. They issue data sharing. They do one write and many reads. They can take advantage of the PCIe as well. Then, of course, the last one is the media. I focused last year, a year and a half, that I've been in Huawei in the media entertainment industry. And you cannot believe how much PCIe SSD and how much SSD implementation is taking place in the media. Their goal is different. They want to do all these thumbnails for the movie that they capture to kind of bring that into the cache. So instead of using the DIMM, they use PCIe or SSD for that purpose. Next, please. So now I want to give you an overview of how Huawei PCIe, which has the best performance into the industry today, and move on forward. How we capture that, how we achieve that, it is really simple. We have two motherboards, the original motherboard and also the daughter motherboards. Our implementation today, we have 3 FPGA attached to DDR3, but we also have a very powerful 10 gig SerDes, which stands for serialization, deserialization, and we have a power loss protection. Our architecture is such a way that because SSD architecture requires lots of read aheads and tweaks, and you are doing lots of fact checking, error checking, you have to have a power loss protection, especially if you're right middle of the write of your database. You don't want to lose that data. So the power loss protection comes to picture. Take that write in case, say, the flash controller goes down. The content is not going to go away. It's going to be done to the flash that is arrowed on the blue. Then after that, when the write is completed, then it powers off. The second implementation that we have, the two motherboards, the second motherboard, the two controllers, they also back each other up. If one controller goes down, say the one to the left, the one to the right will take over, grab all the content of the left one, bring it to the right, send it to the main flash controller, then the system will shut off. Is that powerful? So that's just a brief overview of our architecture. Next, please. Then, because of that architecture, we can achieve the specification that is listed here. So how we achieve this performance? Due to that architecture and other things that I'm going to mention later on in our implementation of the failures and read ahead and power prevention. So our specification is phenomenal. When you look at the read maximum IOPS that value on 4K, 100% random, it is at, for the 1.2 and 2.4 is at 770,000. And when you're doing the stable read at 4K is about 760,000. Maximum read bandwidth, that's very important when you're doing lots of database read write. That's really measure of your throughput. It is 3 gigabytes per second on each. Of course, on 800 gig is lower. But the number that I really want to focus, it is obvious that the throughput and bandwidth is very important. But there's another number that many vendors will shy away from. It is really the write latency. Write latency is very huge for database application as well as the web applications, especially with the web, because if you don't have a very high latency, that means you have to sit on a web refresh page longer. And that's something that companies such as Google, Facebook, LinkedIn cannot put up with. They want the lowest latency. So we offer the lowest latency. And how we offer it because of the architecture that I explained and that 10 gig SerDes implementation as well as of 3 FPGA. And of course the rest is the mixed IOPS. We provide up to 400,000, 430. And later on when I provide the competition, you see we outstand those numbers as well. Power consumption, I have to be very frank with you. Because we have 3 FPGA, our power consumption is a little bit higher. The standard PCIe port gives you 25 watts, but every server today, they have power management, so that those numbers can be adjusted. But these 50 watts and 60 watts, if you're doing lots of write, stressing the system, that's the power that goes to. But in an average use, you're doing a couple of write and many reads, we go about 30 to 35 watts based on measurements. Next, please. So this is our other slide I want to focus. The architecture, the FPGA architecture is very important, but also the algorithm that you implement in your FPGA as well as your ASIC is as important. So Huawei has patented technology for doing dynamic static variable algorithm. Everybody, of course, has that, but ours is more advanced. Our ECC capability, that's our error correction capability, is much higher. It's up 30 bits with 1 kilobyte error correction. We also, not only we support stream technology that which everybody supports, but we also have a technology based on our algorithm that we call it read ahead. Before it writes, it read ahead, make sure the cells on the front are all clean, ready for the write. Our garbage collection is very advanced. Something you want to kind of keep in mind, the difference between SSD and hard drive. Hard drive, there is no garbage collection. Hard drive, they have a couple of sectors designed into the hard drive that any failures or any bad data goes to those sectors. So that is part of the channel mechanism that is based in the hard drive. With SSD, since you don't have that channel mechanism, you have to create garbage collection. When you collect those garbage, you have to make sure you put them in the right place so that your write can be completed very nicely. And that's something that we have implemented. But the failure recovery and failure prevention and real-time protection is phenomenal. We also have something that competition doesn't have. It's called built-in RAID 5 to avoid data loss, just like you have RAID 5 in a hard drive. But we have it implemented in our flash FPGAs. Next, please. So I talked about our performance. Now, this is a true chart, has been measured and verified by third party, which is a storage review that I will point to the website in the end of the webinar. Fusion.io, as everybody knows, they are the leaders in the industry, or they claim they are the leader. But really, when you measure Huawei versus the Fusion.io, you see the number speaks the volume for itself. So if you look at the latency that I was talking about, their latency is 68 microseconds. This is MLC we're talking about. We are MLC, they are MLC, we are 20 microseconds better. But the one that I want to point out, which is very important in a database, is write latency, 15 microseconds, we are at 8 microseconds. This number has been verified with third party as well as the SQL shop that we have and other customers that in the process of OEM in this product. Next, please. These are major operating systems we support, all the famous one as well as Ubuntu. This slide has to get updated. I have to put ready the latest Red Hat as well as the Linux the versions as well as the Ubuntu. We support the version 12 as well as VMware. Next, please. So I'm going to start pointing out to some of the performance, the data that has been done independently, but third party, the result as a storage review. They have done 30 thread average TPS, average response time, 99% total latency. And if you look at it, where Huawei stands versus the Micron, Fusion.io drive 2.1 and 1.2 terabyte. And keep in mind, these are the top of the line Fusion.io drives. We stand, look at, we have 11.7, they are at 13.59. We are at 19.84, they are at 29.35. Huge difference. But when we talk about performance, we also want to focus that Huawei not only has #1 performance, we are also much better price performance. I always like to focus on a price performance because performance by itself is not tied to the price. Really, it's kind of like just a value. We want to focus on price performance, and everybody knows high Fusion.io pricing, but when it comes to the total implementation of price performance, Huawei beats all the competition. Next, please. So this is also another storage review, MarkLogic. This is a NoSQL database benchmark they did. The results are very obvious. Then again, Huawei 2.4 terabyte, got overall average latency of 1.3. 1.2 is 1.4. Then you got Micron is a 1.4A. Fusion IO drive again is very high, 1.7. And then you Variant, which actually was bought up by HDA, for Hitachi now is at 2.3. Then again, we are number one in low latency, overall average latency. Next, please. I want to focus on the 4K 100% read write max latency. This is very obvious when you do lots of read write, random read write. Max latency is the key measurement. This is environment of, again, SQL, NoSQL, the OLTP, any environment that does lots of read writes. So then again, we are very low. The numbers speak for itself. The chart is very clear. We're talking about 7.8, and look at their numbers, 40, 30, and Fusion IO, they have it on a Linux at 51.83, almost 52. Huge difference. And by the way, all this number has been verified by our existing customer as well. Next, please. Then again, 4K, 100% read write. This is throughput now. Remember, it was two measurements on the PCIe SSD. Throughput, that's your performance, how much IOPS you can pump through the bandwidth, how many read write you can do. Throughput is the measure of how many read writes you can do randomly. That's a measure of IOPS, input output per second. And ours, again, 747,867 with our 2.4. Then you go look at the Fusion IO, almost half. I mean, then when you look at the pricing is almost 30% higher than us with that performance. It's just like outrageous. Next page, please. So then again, I want to focus on the customers that they use PCIe, Web 2.0 Internet customers. These are the customers that care heavily about low latency. All the customers listed here, Facebook, LinkedIn, eBay, Amazon, Twitter. These are all that they care about low latency as well as the high performance. ISP, they care about, of course, application acceleration. That's why they take advantage of PCIe. The one good thing about PCIe, we also go to some customers that they say my CPU is really slow because it's really going to his knees. I'm thinking about going to the higher core, spending more money on a server. So I kind of give them a kind of a small lecture that, why don't you try the PCIe SSD first? Implement the acceleration around your application. If that didn't solve your problem, then go ahead and implement a new CPU with higher core. And I'm working with two right now. They are seeing very positive results. And these are life science environment that they're testing our 2.4 terabytes. We, of course, seen this in other environments such as SQL databases as well. And the vertical industry, media entertainment, OLTP, retail, education. Next, please. So I want to close up by indicating the special offer that Huawei has is the fourth quarter. Obviously, Dan can provide you more details of that for our channel partners. It is also listed in our website, HuaweiEnterpriseUS.com, about the details of our special offering for Huawei 1.2 as well as 2.4 terabytes. It's a phenomenal card. It has the highest performance and lowest latency as the numbers indicated. It's easy to install. We offer the best. We trust our car so much. We even give you the best warranty. We offer the warranty up to 3 years with the lowest price available in the market. I just wanted to thank you for your time. I appreciate listening to me. If there's any question, I will be glad to answer.
Thank you.
Well, as a matter of fact, we do have a couple of questions, and I'm not sure if they're all going to be. Can you hear me okay, Dan?
Yep, go ahead.
So we do have a couple questions that came in, so let's go ahead and ask those, and either you or Mo can answer depending on what you think. So the first one is it true that Huawei has an integrated server and storage solution for the HPC market? Mo, I think that one's probably for you. Do we have integrated server and storage for HPC?
Well, high-performance computing, definitely Huawei, hopefully we will have a chance to present our server product line as well. We do have I would say, true implementation of the high-performance computing. Actually, we're going to present that in a supercomputing in 2 weeks in New Orleans. We do have single node 4U. We do have single node 8U. We also have our E9000, which is our converged server product line. That means massive computing upfront and network implementation on the back. Basically, you don't have no top of the rack. You have 10 gig InfiniBand, 40 gig and 100 gig uplink connectivity. Those are the ones that can also take advantage of our PCIe cards in those servers. Yes, that's correct. We do have HPC solution with the PCIe implementation. So I hope that answered the question.
Excellent. Great. Dan, this one could be for you. The question is, where do I get more information on Huawei PCIe products?
Well, a couple of places. So, first of all, you can check with our website, which is HuaweiEnterpriseUSA.com, and there'll be plenty of information there. There will also be these same links that you see on the screen right now to the storage review results that Mo shared with us. All of those links, a bunch of additional information, data sheets, etc., are available right there on HuaweiEnterpriseUSA.com. Another option would be to check with our partner channel, get with your rep there. We can certainly set up a call with one of our engineers to discuss your specific needs and your specific application for these cards or any other enterprise IT needs that you have. Go over those in detail and show you pricing and everything that else that you would want to know about these.
Excellent. Mo, I think this one could be for you. The question is, does Huawei's PCIe application accelerator cards work in competing server models? And if so, are there any advantages to using Huawei servers versus other vendor servers?
Yeah, very good question. Obviously, we work with our card has been verified by R&D at headquarters with many different servers. Obviously, we know, especially in the U.S., we have huge install base of HP and Dell, tested in different type of a Dell platform. I'm glad I have the webinar today, so I can today announce that finally Stanford University verified our PCIe 2.4, and they just placed the PO. So their environment was the high-end Dell R920. Another company that is heavily working with us is While in Memory. They're implementing our PCIe cards in their Dell R720. So we have no issue with the competition. As I indicated, the servers really they're all standard Intel motherboards with the Intel CPU as well as well certified DIMMs and RAMs from either Samsung or Micron or etc. What makes our I'm not saying our PCIe works better in our servers. I have to be honest. Our PCIe follows PCIe standards, so it works well in every server. But what makes a difference with our PCIe on our server, we provide you a better total price performance.
Got it. Okay, a couple more questions. Dan, this one could be for you. It says, I want to see a demo of the Huawei PCIe card. How can I arrange that?
Absolutely. That's not difficult at all. We would arrange that through your reseller, your partner. So get with them. They can get with us, and we can set that up and get it out to you so you can test it in your own environment. We know you're going to love it, so we're absolutely willing to get those out and have you play with them.
Excellent. And then, Mo, there was a question. You mentioned that Huawei was going to be exhibiting at the supercomputing show, and they just wanted one more time, when is that and where is that? What city is that in, and when is it?
Yeah, so supercomputing actually starts on Sunday. The exhibit is opens with the reception at Monday, November the 17th at 6 p.m. So it's from November 17 all the way to Thursday, November 20th at New Orleans Convention Center.
That sounds like a good time. And you're going to be there, Mo, aren't you going to be there personally?
Yeah, I'm personally going to be there. I have a couple of appointments with Ohio Supercomputing as well as National Science University from Chicago.
Fantastic. So if you want to speak to Mo face-to-face and really dig in on all the details around Huawei storage and application acceleration, he's going to be your guy. That is the last question that we had from the audience. So at this point, just any final comments, Dan, that you want to give to the attendees?
Just that we appreciate you being on today. We tried to keep things short and sweet, give you the most relevant information, so hopefully that's been helpful. As a follow-up, as I mentioned, contact us, contact your partner, and we'd love to set up a time to talk to you more in depth about your specific environment and what needs you have that we can help fill, again, with our mantra of high performance, low cost. So we look forward to talking to you very soon as we set up those follow-up calls and talk specifically about your environment.
Excellent. Well, thanks again, Dan, and thanks, Mo, very much for all your technical detail, and we will hopefully see you all on another Huawei webinar in the very near future. Thank you all very much for attending.
Thank you very much.
Thank you, everybody.